Hello everyone and welcome to DataLink. In this opportunity, we are going to build a very simple topology where the main goal is to implement Ansible on a Linux PC to retrieve some data from a Cisco router. And yep, that's going to be the topology, a very simple one. Let's start building it. We're going to need a Cisco router, our Linux PC, and in this Linux PC we don't have Ansible yet. We need to get access to the internet in order to install Ansible, so we need this NAT cloud here. And let's start doing the connections. We're gonna connect our Cisco router EOO to the Linux PC and EO1 to the NAT cloud. Let's make it a little bigger so it's easy to see. Right. Okay, that looks a good size. And then now let's check our ports. This is gonna be EOO, which is going to be facing the internal part of our network, and EO1 is going to face the external part. And here we have ETHO, the port or our Linux PC. All right, and in the internal part of our network, we are going to use static IP addresses. So let's say for the router we are going to define 172.16.01 in this part, and for our Linux PC it's going to be 172.16.010 here. Yeah, all right. Now we can start running this simulation. And open the terminal and the command line interface of our Cisco router. I'm gonna put the command line interface of our Cisco router in the top part of the screen, and at the bottom we are gonna put the terminal of our Linux PC. Alright, and then what we need now is to set up the static IP addresses on the PC and on the Cisco router. Let's start with the PC, and in order to configure here the IP address and a static one is by modifying this file, which is located in etc network and interfaces. As you can see, this is already filled file to do the configuration of the IP address on the Linux PC. In this case, it's gonna be a static IP address configuration, and in order to do that we need to uncomment these 6 lines here. If it were a DHP that we want to use, we need to uncomment these 2 lines here. Okay, let's start editing these 6 lines for our static IP address configuration. We're gonna need these ones, and here we start to define the IP address. We are gonna use 172.16.010. We didn't mention the mask, but let's use 24. It's gonna be fine. 172. Again, 72.16.01 is gonna be our gateway, which is the same IP address that we are gonna configure here in our Cisco router. Although we still don't have access to the internet, we are gonna use the Google DNS server, which is well known as 88888, and that's it. That's all I need for our static configurations of the IP address here in the Linux PC. Let's write and quit. And finally, one more step to complete this configuration is execute this command if app, and the interface ID in our Linux PC, which is ETHO, and with that the configuration should be completed. As you can see, ETHO is now 172.16.0.10, and yeah, the mask is 24. Let's verify. The gateway, I think it's show route. Oh, IP route. Yep, the gateway is 172.16.01, which is correct. And yep, as a next step, let's configure the static IP address on the Cisco router as well. So Cisco router, usual configurations, config terminal, interface EOO, it's gonna be IP address 172.16.0.1 and the mask 24, so 255.255.255.0, and unshut the port. With that, I should be able to do ping from the Linux PC and have a reply from the Cisco router. Let's check it out, and yep, we have a reply. It's already configured. This is for the internal part of our network. For the external part, we are going to be using a dynamic IP address, and then the idea is to use DHCP or enable DHCP on this port here. Oops. And okay, let's access to interface A01 IP address and DHCP. No shutdown. And in a moment we should be receiving a message that confirm the port E01 was configured with a dynamic IP address that was assigned from this cloud here. And here we have this message: interface E01 assigned DHCP address 192.168.122.134 with mask 24. Yep, let's check the configurations on our interfaces. Here we have EOO 172.16.0.1, which is the static IP address we just assigned manually, and for E01 192.168.122.134, both interfaces are up, so it should be okay. Okay, at this point we still don't have access to the internet, and we can verify it from our Linux PC by doing ping, let's say, to Google. Yeah, we will not have a reply. And if you remember some networking concepts, you will realize that the packets that we are sending from our Linux PC has as a source IP address 172.16.0.10, and it goes all the way through this router up to the cloud with that source IP address, and that 172.16.0.10 is not an IP address that the cloud recognizes. So at the moment of replying, the cloud doesn't actually know where to send that. In order to have a reply, we need to configure a network address translation on this router. So we need to convert this private IP address into a public one here, and in order to do that, let's start defining which ports are inside and outside. Interface AOO. If you see, this interface is inside, so APNAT inside, interface AO1, APNAT, this is outside. Okay, and to continue with the configuration of network address translation in the router, we need to define an access list. Alright, the access list is gonna be called access list 1. We're gonna permit, we can permit all the addresses with any, but let's just remember a little bit of IP addressing, and let's say we are just gonna allow the IP addresses that belong to this subnet 172.16.0 with masks 24, and this is done as follow: 172.16.0.0, and the wildcard mask it's 000.255, which is a wildcard mask for 24. So this means that everything that is within 172.16.0 from 1 to 255 is allowed to access to the internet, or it's gonna be allowed. And finally, we need to enable network address translation, and specifically we are going to be using port address translation. So let's start APNAT inside source list is the access list we just created is one interface, and here we put the interface that is facing the external part of the network, which is O1, and finally overload, and that's it. Now network address translation is already configured. We will test access to the internet one more time here, and now we have reply from Google, so that means that we already have access to the internet from our Linux PC. And why do we need access to the internet in the first place? It is because at this moment Ansible is not a command that is recognized here in this Linux PC, which, by the way, I have to mention that we are using an Alpine distro. It's not Ubuntu or any other well-known Linux distribution. The good thing about this Alpine is that it's very lightweight, and if you think about the resources that your PC has to use to make some topologies in GNS3, choosing Alpine is a good option to save some resources for your CPU. Alright, so we need to install Ansible. And the way we do it, the way we install applications in Alpine Linux is a little bit different from Ubuntu. We use APK. Let's update first our repository, then APK add Ansible, and here we kick off the installation of Ansible. Meanwhile, what we can be doing is enabling SSH on the Cisco router. SSH is a requirement for Ansible to connect to the network device. By using Ansible, we need to enable SSH on this one. Alright, let's start by defining a host name. Let's say it's gonna be R1. I need to define a domain name. Let's use cisco.com as a domain name. Crypto key generate RSA, and let's use 1024 bytes. Oh, no. You want to replace? Yes, 1024. Alright, it says that SSH is enabled and we are using version 1.99. Just to make sure if everything is okay and compatible, let's use IPSG version 2, the latest one available here. As a next step, we need to configure the lines, PTY lines. 0 to 4 in this router, and we are going to define here that the login is going to be local, and next we need to enable SSH. In this step we can enable SSH or just telnet, or if I need telnet and SSH, we put all as a command. So this way both are enabled, but for this example we just need SSH, and with this we are saying that enable SSH, but telnet is going to be disabled. Anyway, we will not need SSH for this example. And finally we need to define a username and its password. Username, for the sake of simplicity, we are going to be using as a username password always Cisco. This way it's going to be very simple to remember. Password Cisco. Okay, probably at this point somebody is saying why you're using password instead of secret, which is more secure. Well, first of all, this is just a simulation, it's not a production environment, so whether password or a secret is okay, but as from my experience, choosing password over secret is much better or advisable for a lab environment. When you are working on a lab environment, you don't want to make it difficult for your peers to know which is the password that you are using, and in case collaboration, it's easier for everyone to check in case of any troubleshooting needed. Alright, and finally we need to enable a password here as well, which is gonna be Cisco. And why do we need this? We need this one because when we access remotely to the Cisco router or any Cisco device, and when we access to the privilege mode or enable mode, a password is going to be needed. If you don't have one, you're gonna get an error. We are gonna see in a moment when we finished enable SSH, and we are gonna access, and so a password is gonna be needed when we hit enable, so we will see it. Okay, at this point SSH configuration is finished. Let's show SSH connections are running, and do show IP SSH. As you can see, SSH is enabled and we are using the version 2.1 or 2.0. We can see the keys as well. Another way to verify that SSH is running is SSH the device from itself. We do it as follow: SSHL the username and the target IP address of hostname. In this case it's the device itself, so 172.16.01. I think it's from here. Cisco 172.16.01. Yeah, Cisco, and here we are now in the Cisco router by using SSH, and now enable Cisco. See, we needed enable to be able to access to the privilege mode, of course, and then we need password. In case we would have not configured a password here, we got an error, so that's why we needed the command here, this one. Alright, how do we know we are accessing by using SSH, since we are using the device itself? So we execute the command who, and as you can see, we just follow the asterisk, and the asterisk is saying us that the connection now is using a BTY line, the user is Cisco, and the location is 172.16.01, the device itself. Alright, let's get out of here and execute who again. Now we are not using the SSH anymore, and if you can see, the asterisk now is pointing out to the console line, and so it's not SSH anymore. Alright, now we have SSH enabled on the Cisco router, and Ansible was just installed in the Linux PC. Let's check it out. Now you can see Ansible is a command already recognized by the kernel here. Let's check the version of this Ansible. So you're using Ansible version 2.10.5, and we can start watching or verifying some important items in Ansible. But before doing that, I think I mentioned before, but Ansible needs SSH access as a requirement. So we have SSH enabled on the Cisco router, but let's verify if we in fact can access by using SSH from the Linux PC. So we execute SSH. Cisco is the username, and the target is 172.16.01. Alright, SSH is not found. SSH command is not recognized. Yeah, it is not. Okay, this is one of the disadvantages of this Alpine Linux. This distro is that it's so lightweight that it doesn't have some of the applications that we might need while using Linux. Anyway, it's not a big deal, we can install it anyway, so let's install it. We are gonna use let's say OpenSSH. Alright, let's verify now. Now SSH is recognized by the shell, so let's try this again. What is saying this now is unable to negotiate with the Cisco router on port 22 because the key exchange is not matching. Okay, it seems that we are using a different key exchange than the one that the Cisco router supports. We should be using one of these. Alright, basically to sort this out, we need to define here which key exchange method are gonna be using, or encryption algorithm if you want. Alright, and this is done by using this command okix algorithm. Algorithms, in fact, and we need to add the algorithm method. Where is the plus? Here it is. So we can choose any of these that is supported by the Cisco router. Let's choose, for example, this one. Diffie-Hellman group 14 SHA1 space here and try again. Okay, now the problem is that the cipher found is not matching, so the Cisco router support one of these. We need to define the cipher method as well. Right, it's not a problem. We define the cipher method using this option in the command, and again we can use any of these ones. Let's copy this, paste, and here we have now yes, and the password is Cisco, and we are now in the router. Let's enable again Cisco and execute who. If we can see now, we are using the BTY line O and the user is Cisco, and the location is 172.16.0.10, which is the Linux PC. That means we are accessing by using SSH from the Linux PC to the router. Alright, that's it. We close the connection and we are almost ready to use Ansible. Okay, let's check again Ansible version. And so going back to what I was saying is that config file is one of the first items that we need to define when working with Ansible, because in config file we define the connection method for SSH and some other variables that we might need, like for example we need to define where inventory file is going to be located. We are going to talk about the inventory file in just a moment. Let's first define or create the config file. In some other older versions of Ansible, the config file is usually located on the here. Let's see if the file exists. etc Ansible, but the directory doesn't exist, so let's create the directory Ansible. And now let's create our config file with BI editor. And our config file, we will call it Ansible, and the extension of this file has to be CFG. CFG. Now we hit enter and we are inside the text editor. And as a first line for this config file, we need to put the keyword defaults within square brackets. And the second line, we define the transport method. Previously we used OpenSSH to verify SSH connection to the Cisco router, but what Ansible uses instead is Paramico. So let's define Paramico here as a transfer method, and for this small example we just need to define now the host file, which is where the inventory file is going to be located. Let's locate this in the directory we just created, etc Ansible, and we are going to call this host file or our inventory file as hosts. Alright, that's all I need. Write and quit, and let's verify Ansible version again. As you can see now, config file is defined now with etc Ansible CFG, the file we just created. Okay, moving on. As a second important item is the inventory file. the inventory file, we can create it right now, etc Ansible. We said that it's gonna be called hosts. It's a file where we can list all the network devices we intend to access from our Linux PC. In this case, it's only one, this router here, but it might be like 10 routers, I don't know, 50 routers and 100 switches plus servers. It doesn't have to be just network devices, it can be servers as well. It can be another Linux server over there. Like in this file is where we list all of them, and we can create groups to make it convenient to access to different groups. We can do a lot of arrangements depending on our requirements here. Okay, for this small example, we just gonna list our Cisco router, and as a first line of our inventory file, we are gonna define a group. We're gonna call this group routers, and in this group we can list all the routers that we intend to access. In this case, it's only one. We can put here a host name or an IP address, and let's put the IP address of our Cisco router here, and that's all I need for our inventory file. Okay, now we have our config file, our inventory file, so let's check it out. Here we have our config file, our inventory file. With this, we should be able to verify connection by using Ansible, and we do it as follows: Ansible, and here we put the target, which, if you remember, in our hosts, let's visualize our hosts. Host file, which is our inventory file. Yeah, it's etc Ansible. Our inventory file contains just this one, but we created a group called routers. So for Ansible command and defining the target, now we are gonna say let's use routers as a target, which is the name of this group here. And to verify connectivity by using Ansible, we are gonna use this command, which is a ping, and let's run it. Alright, what's the issue here? No authentication method available. One way to do troubleshooting while executing Ansible commands is by running the verbose mode. We use 2 times hyphen and 2 times B. Alright, this is not running. Oh, what? I think it's 3 times V. Oh no. Only 3 times B. Yeah, it was 3 times B. Only 1 time hyphen and 3 times B. And we can get the logs that allow us to do troubleshooting. Okay, here we have establishing paramicro SSH connection for user. The user is not defined on port 22. Alright, we need to help Ansible to understand which one is the user for this connection. We can do it in different ways, but we are gonna use now the inventory file and add some data here to help Ansible to understand about the user. All right, so we need to add these keywords here: Ansible, user. The user is Cisco. Yep. Let's execute this again. No authentication method available. Okay, now we have parameter connection for user Cisco port 24.2.1. Alright, probably what we need now is to define or help Ansible to understand what is the password as well. So we need to define another variable here, Ansible password, and the password is Cisco, if you remember. Right and quit and run again. Alright, at least now the root of the error is different. File to open session. We are executing Cisco. Okay, what's happening now here is that if you see, we are executing this command and in the Cisco router, but you know, this echo command is not recognized by Cisco. So we need once again to help Ansible to understand to which device it is connecting to. So let's Ansible connection is a network command line interface. Yes, because remember, Ansible is not just for network devices, but it can also be used for the servers and different other platforms as well. And talking about platforms, it can be, it is not just intended for Cisco, it can be another vendor as well, like Juniper or Arista, I don't know. So we need to Ansible understand as well which operating system this network device is using. It's not just the network command line interface, but the operating system as well. Ansible network, and the operating system that we are using is iOS, Cisco iOS. Okay, with this it should be good. Now let's run it again one more time, and success. We now have a reply, on reply to our ping command by using Ansible. So we are good to go further. So far we saw two important items on Ansible: the config file, the inventory file, and the next one that we are gonna check now is the playbooks, or we are gonna be creating a playbook as well. And inside the playbook there are some other concepts that are important for Ansible. Let's create our playbook file, and again we are gonna use bi text editor, ets, and the directory we created. Let's call our playbook, I don't know, since we are gonna be retrieving data, let's call it collect. These playbooks are YAML files, so we need to use YAML extension. And let's start creating our YAML file or our playbook. So inside playbooks we can have more than one play. For every play we need to define some parameters, and for every play we can have more than one task. So for this simple example, we are just going to be using one play inside this playbook and only one task. As a first line for an Ansible playbook, we use 3 hyphens. Another important thing that I have to mention for playbooks is indentation is very important for YAML files. So next we define a name for this play. Names are just as a command, it doesn't have any effect on the playbook itself, but it's just for a good documentation, a reference that allows us to know what the play or this specific play is doing. Just put sample, for example. And next, the target. In this case, let's use routers, which is the group we created in our inventory file, remember? Alright, this is some of the keys we need to define for every play we create inside our playbook. It can have more keys here depending on the requirements, but for this very simple topology or example, we just need these two basically. And let's create now our tasks. Let's create this task now. Inside every task we define what is called, or we use what is called modules. And modules are another very important topic in Ansible. We have more than 700 modules that we can use in Ansible. These modules depend on the target device. As I said before, it is not just for Cisco devices, it can be Juniper, Arista, I don't know, Palo Alto, some other vendors as well. And then we have for every one of these devices or servers different modules, and these modules have some documentation that you can find in internet, specifically on Ansible, on the Ansible website. And yep, in this documentation you can check how to use these modules. And for this example we are going to use a module called iOS facts that will allow us to collect data or retrieve data from the Cisco router. Again, inside task we can define the name, which will allow us to understand what we are doing inside this task. Let's say, for example, collect data, and then it comes now the name of the module, Cisco iOS facts. Again, indentation, gather subset, again this is all in the documentation of this module. Config, what we are going to be collecting is some data that usually is displayed when we execute version command on the Cisco router. Some additionals, print out This is to print out the outputs on the terminal, and finally debug. And that should be it for our Ansible playbook. Let's execute this one. Okay, now to execute our playbook, we use Ansible playbook command, and we specify the name of our YAML file or the playbook, which is collect YAML. YAML couldn't be found. Okay, it's because the location. Ansible. Okay, there is an error on the name line here on our playbook. Error: task is not a valid attribute for a play. Oh, yet let's check. Yeah, it's actually not task but tasks. Let's correct this one. So tasks, and let's see if it fixed the error. Yeah, seems that now it's running. Okay, we have at this point connection to the router, but something will happen. What happened now? Is the Cisco ios.ios facts module is not working well. Gathered equal subsets. Yeah, according to the documentation, gather equal subset is not inside the parameters. We need to check this again. It's not gather equal subsets, but gather underscore subset. My bad here. Okay, let's go. Let's write and quit and check again. Alright, so far so good. Connection is fine. And here we have the output. So if you see, we have some useful data here that has been retrieved from the Cisco router, which is, for example, the host name, the operating system, the version of this operating system, the version of the firmware, and some serial numbers here. And let's check if it is in fact the data that we are expecting. Show version. Yeah, let's see. If we execute show version in the Cisco router, we got that the version is 15.41t, which is exactly what is shown here. And some other data might be, I don't know, this serial number 2048001, 2048001. Yep, it is correct. And yeah, with this output, we can say that we finished this example. As you can see, we can use Ansible very easily to retrieve some data. In this case, it's just for one device, but imagine it can be 100 or 1000 routers, and with just one command we can retrieve all the data from these devices. And yep, that's the power of Ansible. Alright, see you in the next video, and I hope this one was a useful one.